now we go back to the last page, and on last Thursday we talked about what is tightening and what is loosening. Tightening 锁紧哈 ，loosen 放松。Now in screws that the bolt tension will exert a force of W onto the surface, and if the actual motion, which is this part, is opposite to W, that we say it is tightening. In this case, and because there is contact between the bolt and nut, 包是螺栓，那是螺帽哈。There is contact between bolts and nuts that we have of course we have contact, normal force, and we have friction. So if we have the resultant of F and N is R here, and the direction of R is phi S from N. Okay, because motion is going to the right, so the friction is going to the left. Okay, the motion is to the right, so the friction is to the left. So, and the resultant of F and N is in this direction, is out in towards the left. Now, if the bolt is to loosen a bolt, the actual motion of bolt is in the same direction as W. It is in the same direction as W, and to loosen it, and because the motion is to the left, the friction is going to the right. So the resultant of F and N is R is going to the right. Okay, so it looks a bit difficult, but let's work on a problem. And we work on the problem of our turnbuckle and 张线器啊，这一秒摸过，从这边。So a turnbuckle that has square thread and radius of R 5 mm and lead of 2 mm. And we know mu S is equal to 0.25, determine the moments M to be applied to draw the screws closer together. So, and we talked about the key parameters on Thursday, that the lead is 2 mm. The lead is 2 mm, which is L. And when we go 1 revolution, the radius is R, and the path length is 2 pi R. And if it goes up by 2 mm after going 2 pi R, the slope here, the slope theta, the slope is 3.64 degrees. So I think you can do this. Now, so let's draw a figure that look like the one before, on the page before. So this is our nut, and this is our bolt. And we have our force of W is 2 kilonewton. We have our force of 2 kilonewton. And we want to tighten it. So we want to tighten because it makes it closer together. So we increase the tension. Tighten, because this is closer together, it is tightening motion. Tightening motion. So for tightening motion, does this bolt go to the right or go to the left? because the force is this way, so the actual motion is this way. So it's going to the right. Let me mark it down. Motion is going to the right, okay? Sorry, our motion. Motion is going to the right. And sorry, let me draw it in red. Let me draw it in red. It's okay. Now, so the problem looks like this. Of course, we still need to draw other forces. We need other forces. So we have 2 kilonewton going to here, and the motion, because it's a tightening motion, so the motion is going against, go opposite to W. Now, we have a, we will put a moment, to the turnbuckle. We will put a moment to the turnbuckle and to put them closer together. So how do we draw M here? The first thing, for this M, because we have 2 screw threads, so the M here would go like half of M is going to the left screw and go half of the moment will go to the right, to the screw to the right. That's the first thing. That's the first thing. So because we have 2 screws, half of them is on the upper half and half of it is on the lower half. That's the first thing. And the second thing is for moment of M, for moment of half of M going here, so the force here is M over 2 divided by R. So this is this one is it looks like this. And do we have other forces to draw here? Do we have other forces to put onto the free body diagram? Reaction, okay, reaction and friction. So reaction, of course, goes to the reaction. Of course, it goes like this, right? It goes like here. How about friction? Does it go to the left or does it go to the right? Because motion is to the right, so the friction goes to the left. I'm sorry, this is N, sorry. It's N. Please take note here. And we have the resultant as R. And R is has the degree of has the angle of 14.04 degrees to N. So of course you can. So we have only 3 forces here. So, or should I? Sorry, I should make this like that. And sorry, I should put it like this. So we have only 3 forces here. Okay. Now, and so we have only 3 forces here, and we need to determine M. Because we have only 3 forces, what can we do? We can draw a triangle of the 3 forces. And this is W, and this is what? M over 2 divided by R. So this is, I think, this one is 2 kilonewton. And I think the rest is easy, because we need to determine M here. So M is equal to what? Or should I write it to the clearer? And this one, what else should I draw here? Phi S is here. So what we know is tangent. Remember, I'm sorry, this is, remember, I made a mistake here. And for this angle, remember that, sorry, let's go back to the free-body diagram. This angle is theta, which is equal to 3.64 degrees. So here we also have an angle of theta here. So for this triangle, this angle is equal to theta plus phi s. Where theta plus phi s is equal to 17.68 degrees. So tangent of 17.68 degrees is equal to M over 2 divided by R, and then times 1 over 2 kilonewton. And therefore, M is equal to 6.37 Newton meter. Take your time to write it down.